80% of every automotive emissions test conducted on Earth by regulators, automakers, and governments goes through instruments made by one company in Kyoto. You have probably never heard of it.
Its name is Horiba. Revenue is $1 billion a year. Market cap is around $2 billion. Operating margin in the mid-teens. By the metrics that usually get companies on Bloomberg, Horiba is invisible. By the metric that actually matters in its business, market share, it is one of the most dominant companies in Japanese industrial history.
This is the story of how a nuclear physicist who couldn't do nuclear physics accidentally built an empire. Masao Horiba graduated from Kyoto University in Tsinchu Fight War with a degree in nuclear physics and immediately ran into a problem. The U.S. occupation forces, concerned about Japan's wartime weapons program, had dismantled the country's cyclotrons and banned nuclear research. If you were a 23-year-old physicist in post-war Japan who wanted to do science, your options were limited.
So Masao started a private laboratory in Kyoto, making whatever the market needed: emergency power lamps, oscillators, capacitors. The plan was electrolytic capacitors, a growth business in a country rebuilding its electrical infrastructure from scratch. He had even developed a glass electrode pH meter as an internal quality control tool. You need precise pH measurements to manufacture high-quality capacitors, and the instruments available in Japan at the time were unreliable.
Then the Korean War drove inflation through the roof and killed the capacitor business. Masao looked around his lab for something to sell. The pH meter, the tool he'd built for himself, was sitting there.
In 1950, Horiba commercialized Japan's first glass electrode pH meter. The company formally incorporated 3 years later. The capacitor plan was abandoned. The accident became the business.
What followed was a pattern that would repeat itself for the next 70 years. Find a technically demanding measurement problem, engineer a better instrument than anyone else has, and defend it through precision.
The emissions chapter began in 1965 when the United States passed the first federal clean air legislation requiring automakers to measure the pollutants coming out of their exhaust pipes. The problem was that accurate measurement of nitrogen oxides, hydrocarbons, and carbon monoxide required sophisticated gas analysis instruments that barely existed in commercial form. Horiba made them.
According to a War Porter Prize citation which Horiba received specifically for its emissions measurement business, the company controlled approximately 8% of the global market for automotive exhaust gas analyzers used in laboratory testing. That share has not materially changed. ABR, an Austrian engineering firm, is the only significant competitor. There is no one else in the market worth mentioning.
Think about what % market share in regulatory infrastructure actually means. Every time the U.S. Environmental Protection Agency certifies an emission standard, every time a European regulator validates a new vehicle type, every time an automaker in South Korea or China or Brazil runs development testing to ensure their new engine meets global export requirements, there is a better than even chance that Horiba equipment is in the room.
This is not a particularly large market. Automotive emission analyzers are a niche of a niche. The global market is projected at around $7 million by Luxohar $1 million by Lee San according to Digital Journal. Horiba's automotive testing revenue is roughly $600 million a year, but a niche you dominate at 100% is an entirely different proposition from a market you compete in.
Then came electric vehicles, and the obvious question: what happens to a company that earns its living testing exhaust when the car industry is trying to eliminate exhaust?
The answer is more complicated than the threat looks. The first thing to understand is that battery electric vehicles don't eliminate emissions testing, they change it. Known exhaust emissions are now a regulatory priority: tire wear particles. Brake dust and road surface abrasion generate particulate matter regardless of whether the vehicle has a combustion engine. New regulations under UNGTR number Trinchonman-Bate testing of battery durability and thermal management. Every EV maker must validate that their battery pack performs within spec after years of charge cycles. Horiba has instruments for all of these.
The second factor is the transition itself. During the shift from internal combustion to electric, hybrid vehicles proliferate. HEVs and PHEVs still have combustion engines that produce measurable emissions. Heavy-duty trucks, cargo ships, and construction equipment will run on diesel for decades regardless of what happens to passenger cars. The combustion world is not disappearing on a schedule convenient for anyone.
But the most important hedge is not in automotive at all. It is in a subsidiary that most people have never heard of, making instruments for a market with structural tailwinds that have nothing to do with cars.
HORIBA STEC, based in Kyoto, makes mass flow controllers, the devices that precisely regulate gas flow in semiconductor manufacturing, in atomic layer deposition, chemical vapor deposition, and etching processes. You need to control the delivery of reactive gases to within fractions of a percent, too much or too little, and the layer doesn't form properly. The chip is defective. In a Hupodoran wafer with Lokfek dies, a fraction of a percent measurement error is not a precision problem, it is a yield problem measured in hundreds of thousands of dollars.
HORIBA STEC controls approximately 60% of the global mass flow controller market for semiconductor fabs, according to industry analysis. This is a different business from emissions testing, more technically intensive, faster moving, with more direct exposure to the semiconductor capex cycle. But the dynamics are recognizable: a narrow technical problem, solved more precisely than anyone else has managed, defended by switching costs that no customer wants to incur.
As a chip demand has accelerated, so has HORIBA STEC. In January, Nisen Nisruk Horiba brought the Fukuchiyama Technology Center to full operation, expanding mass flow controller production capacity up to 3 times its previous level. In April, Nisen Arsavor Horiba acquired Atamax, a South Korean chip measurement tool maker, adding capability in the world's second-largest semiconductor manufacturing nation.
H1FY2 results confirmed the trajectory. The materials and semiconductor segment, HORIBA STEC's home, grew operating income by 12.9% year-over-year. The automotive segment was flat. The transition is visible in the numbers.
Horiba's FY25 full-year revenue was 333 billion, roughly 10.4 billion at current exchange rates, with net income up 2% to 39 billion. The company has guided FY26 to 345 billion in revenue, and raised its dividend to 40 chusen per share.
For a company of this size and this market position, it remains almost entirely absent from Western financial media. Part of the reason is structural. Horiba's customers are governments and engineers, not consumers. There is no product to photograph, no CEO who gives TE talks. The instruments look like refrigerators with screens.
The other reason is the kind of specificity Masao Horiba was drawn to from the beginning. He was a nuclear physicist who became a pH meter manufacturer because that was the problem in front of him. He built emissions analyzers because the Clean Air Act created a measurement problem nobody had solved. He called the company's philosophy joy and fun, Japanese omoshiro okashiku.
which the company adopted as its official motto in Sen Q Hak Nunasdra Hatch. Not because he was trying to be eccentric, but because he genuinely believed that curiosity-driven problem-solving was the only way to do the work well.
That philosophy is embedded in Horiba's corporate structure in ways that are visible to anyone who looks. The company runs research labs that work on problems years before they become commercial. It acquires businesses not to consolidate market share, but to pick up technical capability. It expanded into Australia in January specifically to build local service presence for water quality analytics, a $30 million global market that is too small for most multinationals to bother with, and exactly the kind of niche Horiba has been targeting for 70 years.
The Japan factor here is this: Horiba is what happens when a Japanese company decides that precision in a narrow problem is worth more than scale in a broad one. Masao Horiba did not set out to dominate emissions testing, he set out to make the most accurate pH meter anyone had built. The emissions market came to him because accurate measurement of gases is hard, and hard problems, solved reliably, become the infrastructure everyone depends on.
The question for the next decade is whether HORIBA STC can play the same role in AI chip manufacturing that the automotive division played in emissions compliance, becoming the invisible baseline that every major fab takes for granted. The Fukuchiyama expansion suggests Horiba thinks it can.
If you want to keep up with stories like this, subscribe to the Japan Factor. In Shinshu Fax, a physicist who couldn't do physics built a pH meter by accident. In one Fu Shinshu Fax is the foundation of two separate global monopolies. The next one might be in the machines that make AI chips, or it might be in something nobody has thought to measure yet. Word count, sin Wamarschen Forschen Idstimited duration mo 1 Forscher a Fiur sub Siur subminado 1 Forscher a Shin Forscher a Fiur sub iteration.